Bangalore location of DRDO and Indian Railways. So we all know how that things will happen. This is 192.168.2.1 and this is 1.1 and 192.168.2.1 and so on and so forth. So we all know that the tables are created. The RIB, LIB, FIB, LFIB all will be created and the packet can move from Indian Railways of Hyderabad location to Bangalore location. But the logical problem in this is that DRDO is also using the same IP schema. He is also using the 1.1 and 2.1. So if he is also using 1.1 and 2.1, and we have seen in the previous slide that the local label is actually created based on the destination IP address. So we know that if it is 2.1, he will have a local label of 101. So that will actually create the confusion for the last router whether he wants to give it to this, which is Indian Railways, or to another interface, which is interface number 4, and give it to DRDO. So this is a real world scenario wherein the router number 4, the provider edge router, is connected to two customers which are using the exactly same IP schema. So we need to resolve that problem. We need to resolve the problem of not wrongly giving the packet of Indian Railways to DRDO. Fine. So that is our requirement now. That is our problem. Now we are able to create the tables and we are able to forward the packets, but we are not able to isolate between DRDO and Indian Railways, for example. So let us see how do we achieve that. We will achieve that with the help of VRF. VRF is the virtual routing and forwarding table, or the VRF instance, which is virtual routing and forwarding instance. Okay. So the customer isolation on the provider edge router is achieved by the virtual routing table called the VRF or the VPN-RF, that is virtual private network routing forwarding instance. So that is done with the help of the VRF. Why do we need to isolate the customers? Because as we have discussed in our example, the Indian Railways and DRDO, it is very likely that they would be using the same IP schema in their internal network, and they have to be isolated so that the packets are not sent to the wrong destination. So we make VRF.
Ankurji,
yes.
Even though they are different networks, we have to use VRF, no, to avoid the communication between those departments.
We have to use, obviously we have to use, but had they been different, it was not a necessity. It could have been achieved, but that is in a practical scenario. Even if Indian Railways and DRDO are using differently, there could be customers who are using the same IP schema. So this is just to solve a practical problem. The VRF is mandatory. That's what I would say.
What I am asking, if they are using different networks also, to avoid the communication between two these organizations, we have to use VRFs, no?
See, if they are using different IP schema, it will still work. The basic functionality will still work.
But they communicate each other. That should not be.
Yeah, they will be able to communicate with each other. The basic work. But the MPLS has been designed in that format. If you do not initiate a VRF, it will not allow the communication. That's what I'm trying to say. That VRF is a mandate now. If you are not assigning that customer in a VRF, it is not, the configuration is not complete. So even if you can achieve your objective, the router will not allow you to achieve your objective because VRF is a mandate.
Okay.
Okay, fine. So VRF also contains the VPN identifiers as well as the VPN membership information, that is RD and RT. So these are the two things in a VRF. It contains the route distinguisher and the route target. So route distinguisher is called the VPN identifier and route target is the VPN membership information. So these are the two important attributes in a VRF. Okay, so that is an RD and RT. Let us see what an RD and RT is. Before that, this is just a pictorial representation of the previous slides only. That is, there is a customer site A, there is a customer B with site 1, Indian Railways and DRDO. they are going to the same router. They are going to the same router. This is the provider edge router. But that same router will actually have a VRF for customer A. VRF in a layman language can also be called a virtual router. In the same physical router, there is a virtual router for Indian Railways. There is a virtual router for DRDO. What happens is that Indian Railways feels that the entire physical router is his router because a virtual router has been created. See, the question which was being just asked, that why without VRF we cannot work? We cannot work because it's now a mandate to do so. Otherwise, if there is just one customer, then that entire physical router can be given to that customer itself, if the scalability is not a question. But because we can have multiple customers to the same physical routers, VRF, which acts as a virtual router for that customer, is created. So this VRF for customer A can be given a name such as IR. This VRF for customer B can be given a name such as DRDO. So IR is the router for Indian Railways. DRDO is the router for the DRDO customer. So it is what is just being shown is that any protocol, static, RIP version 2, OSPF, EIGRP, BGP, they can all come, and that's what the physical interfaces or the logical interfaces are there. Just a representation of what is happening. So route distinguisher, like I was talking about, a VRF actually has two things, route distinguisher and a route target. So a route distinguisher is nothing but a provider edge router, provides isolation between customer using VRF. You all know that. Now information needs to be carried between the provider edge routers to enable data transfer between customer sites to the MPLS VPN backbone. So that also we know that the information which is there between the provider edge router number 1 has to go to the provider edge number router 4, which is directly connected to the destination, through the MPLS backbone, through the backbone of router number 2 and 3. But because we need to isolate them, so an RD, which is a 64-bit unique identifier, is prepended to the 32-bit customer prefix or route learned from a CE router. What happens is that IP that was 192.168.1.1 is actually prepended. It is actually prepended with a 64-bit unique identifier. So here, this is already a 32-bit information. This was not unique. 1.1 was being used everywhere. So it is prepended with a 64-bit unique identifier, which is called a route distinguisher. As a result, we get a 96-bit unique address that can be transported between the provider edge routers in the MPLS. So why the route distinguisher is being used? It is used in order to make that 32-bit IP address into a unique address which can be transported in the MPLS domain. After adding the 64-bit information, it becomes a unique 96-bit. That 96-bit will be different from the DRDO 96-bit address. In the 96-bit address of Indian Railways and DRDO, the 32 bits are common. The first 64 bits are different, making it a unique 96-bit address. Then we have a route target. A route target we require because additional identifiers which are used in the MPLS domain, they identify the membership of the routes learned. So identify the membership of the route learned on that particular site means from the particular site of Indian Railways or DRDO, they will identify the membership. That means they will identify that that particular route belongs to Indian Railways or to DRDO. So two things you need to identify the membership of that route and you need to make that route a unique route. Okay, so in this case you use the extended BGP community. That's just a attribute of the BGP protocol. The export and the import targets are used. That is, you get RT also has two things in it. It is not a simple, I would say a simple RD. RD was a simple 64-bit address. Now RT has two things in it. It has a route export and it has a route import. Okay, and each of that route export and route import is another 64-bit address. So you have a RD, which is 64-bit, you have an RT export, and you have an RT import. So their format is same like RD, that is they all are 64-bit. This is used to make that root unique. These are used to identify the membership to that particular site. In the sense to that particular VRF. Okay, these VPN labels are per root or per forwarding instances. They are created, this RD and RT are actually created for every forwarding instance, that is for every VRF. They're all pre-calculated. So this is the working of the RD, RT and the MP-BGP. So just like the previous slide, we have discussed how the IP MPLS tables are created and the packet moves from the source A to destination B. We are expanding that understanding to have two different customers. Okay, so to have two different customers in the sense, we have the Indian Railways in blue, we have DRDO in red. Indian Railways in blue as the schema 192.168.1.0/24 at the site 1, which we can consider as Hyderabad. It has an IP schema of 192.168.2.0 at the site B, which we can consider as Bangalore, that is 2.0/24. Same way, DRDO is also using the same IP schema, 1.0/24 and 2.0/24 at Bangalore. They are also connected to the same provider edge router, PE1. They are also connected to the same provider edge router at the end, that is PE2. So 192.168.1.0 of India and of DRDO is to the same provider edge router at Hyderabad. 2.0 of Hyderabad Indian 2.0 of Indian Railways and 2.0 of DRDO and again to the same provider edge router in Bangalore. Till this point, this is all black. This is being given the color blue and red after the VRF, RD, RT comes into picture. Till this point, it is all black in color and the provider edge router will treat it equal. But we don't want to treat it equally. We want to isolate the two customers. So what we do is we assign a VRF. Okay, so this is a VRF. So we give a VRF, we give one name to the VRF. That same name will be here also. That is a VRF. Okay, we give another VRF, that is RE0, 1, whatever we can give, and this is a red. That means we give a VRF red, we give a VRF blue. So the VRF for the blue customer, we can call it as a blue 1 and blue 2, and this is red 1 and red. That's for the, I would say, clear understanding. The names of the VRF have been kept separate, but it is actually the same VRF. VRF will be just Indian Railways is a VRF for that particular customer. The moment you create a VRF, a virtual router, this is a virtual router, is created for Indian Railways and for DRDO in the same physical router, which is a provider edge router. Fine. The moment you create the VRF, you will also have the RD and RT values. How does that happen? An RD value is locally created, that is, it will have an RD value of 100:12. RD value, like we discussed, is a root distinguisher. That is a unique 64-bit address. So that 64-bit address is something like 100:12. That is generated for that instance, for that VRF instance. 100:12 will be generated for that VRF instance. So RDs are created. Now he will generate a root target export. Root target export will be 100:102. That 100:102 will be imported. So that will become an import for the site 1. Okay, or the site 11. So the root target export that is generated by the site 12 of 100:102 will become an import for the site 11, which is 100:102. The 100:101, the root target export created locally by site 11 will become the import for the site number 12. So that is how the, I would say, the classification happens for the route distinguishers and the route targets. How does that happen? The moment you create the VR. The virtual routers are created and the route distinguisher and route targets are being created. So same way, an RD will be created for the DRDO customer, that is 100:21 and 100:22. So that is different. That RD number is different from railways. There it was 111 and 112. Now it is 121 and 122. Okay, so it will be prepended. It will be prepended to the destination address, that is 2.0. So 100:12 is being prepended to the 32-bit address, making it unique. And this 100:22 is being prepended to 2.0, making it again unique. So the route distinguisher of 64-bit address has been prepended to the 32-bit address, making it a unique 96-bit address, which can be transported onto the MPLS domain. But then to identify the membership to that particular VRF, it is also given a route target value. So a route target value, that is a route target export value, which is 102 in this case, which is here, and 202 in this case, there comes in. So the route distinguisher and the route target export are added, and this is what is being transported to the MPLS domain. And the addition to that would be, it's no longer like the BGP protocol will not be useful in this case, because BGP protocol is used for the IP version 4 addresses to transport these VPN v4 addresses. This is not a normal IP version 4 address, right? This is not a normal 32-bit address. It is now a 96-bit address along with the route target information. This VPN v4 96-bit address is being transported using an MP BGP protocol, which is just an extension of the BGP protocol, which is multi-protocol BGP, which has been created in order to transport the unique 96-bit address on the MPLS domain. So what happens is that this blue thing was the IP packet. That IP packet, which was not unique till the point it was a simple IP packet of 2.0, has now been converted into a unique 96-bit address by adding 100:112, by adding the RD, and along with the RT export, that is the 100:102, it has been transferred. So it becomes a unique thing, and the customer isolation is achieved and the transportation also happens. Okay, so I would say we would take questions at this time to have more understanding onto this, and then we will proceed further if time permits.
Sir, VRF is done manually or is a protocol?
You would have to repeat the question. Your voice was actually breaking in.
And VRF, sir, is done manually or it is a protocol?
The VRF is done manually. You have to assign a VRF with that name. So if a VRF name, it is case sensitive also. So if that same VRF has been assigned elsewhere, it cannot be reused in that time.
Is assigned at provider as router or customer as?
It is provided by the service provider. Customer has nothing to do with the VRF because customer is not using the MPLS. So it is the job of the service provider to assign the VRF. See, MP BGP, we would not be covering that in details because, or maybe in the troubleshooting classes or in the advanced sections, it would be explained. What I would say is, because there is no point of going on to MP BGP before having the sessions of BGP. What BGP itself is a very vast protocol. So what you can understand at this point of time is MP BGP is multi-protocol border gateway protocol. Because in an MPLS domain, it is no longer an IP version 4 address that has to be transmitted. That is, it is no longer a normal 32-bit address that has to be transported. It becomes a 96-bit VPN v4 address. You require a protocol called MP BGP, which will work in the same fashion as BGP, just a name for transporting the VPN v4 addresses. BGP is used for transporting the IPv4 addresses. MPBGP is used in the MPLS domain to transport the VPN v4 addresses. Okay, there is
one doubt, sir. This RD, you told that 64-bit is added to the 32-bit for existing IP. This RTE and RTI is also part of that 64 or another 64?
That is another 64.
Another 64. RTE also another 64. RTI is also another 64.
Yes.
Is it so? Oh.
Yes, indeed, it is that way only. And the reason why they are additional 64, because they have a different function. The addition of an RT export or an RT import is not to make the address unique, but it is to identify the membership. So that export import, like it has been shown here, it has to be exported, that has to be exported and that has to be imported. So they are another 64-bit addresses. So that's why, that's how it becomes unique and the membership having ID.
RD is added for root distribution.
No, the one.
In that case, you have shown there is a blue color, red color is bottom one. 100, 12, 192, 168, 2.0, then RT 100 colon 102. So this is altogether, this is 96, another this is 64.
Exactly. So this thing is, this blue color, this part is 96 because it is
right.
32 and this thing is 64 and this is another 64. Yes. Yeah, MPLS supports IPv6. Yes, that would be different. It will not be a VPN v4 address. It will be a VPN v6 address. It will be VPN v6 address. That 64-bit RD will be prepended to the 128-bit IPv6 address and making a VPN v6 address. And it will also have an RT export of 64-bit.
Sir, kindly explain the significance of RT.
The significance of RT, like I have explained in this previous slide, is to identify the membership. It has to be identified for that particular root. Unique 96-bit will remain the same. That unique 96-bit pertains to which customer will be decided by the RT export. It is separate to the 34-bit and 64-bit. It is an additional export information, which is 64-bit. And that 32 plus 64 will make it unique. But where it has to go, it has to travel in that VRF. Otherwise, it will keep on traveling and it will keep on increasing the load onto the routers, right? That router, which is the virtual router, should go to that virtual router only. It should not go to that virtual router. Sorry? What will be 96 in IPv6? Right. Correct. It will change.
It may become 192.
IP version 6, that unique 96-bit address will become a unique 192-bit address.
192-bit, 192.
Yes, because 128 is already IP version 6 and another 64-bit will be added.
This root distinguisher is understood. So can you explain once again root target? What for root target?
Root target, that explanation is the same only. I will repeat because that is the basic explanation. A root target is required to identify the membership. Identify the membership in a sense that this 96-bit address, which is 64 plus 32, that 96-bit address belongs to Indian Railways or that belongs to DRDO is decided by the root target value. That is the case. Okay, so now next question which I can see in the chat window is that does VPN gateway has any role in this process of VRF? VPN gateway. You will have to expand on what do you mean by VPN gateway. Any router can be a gateway router. After VRF, can one A and B communicate with each other or not? After VRF, can CE1 of A and B, they can communicate. That is another advanced concept which we shall not discuss. It is related to route leaking. You will have to manually leak the routes of customer 1 into customer 2. That means you will have to manually leak the routes in the VRF of Indian Railways into the VRF of DRDO. How that is useful? That is useful in some practical scenarios such as where there is a stub configuration. There it is useful. Now that is again a different topic to discuss. Let us not discuss it, but it is possible. Simple answer, it is possible. Okay, and RT, no bits. No, RT has bits. RT is a 64-bit address. The root target is a 64-bit address. This is maybe after the break, we will just go through this overview and then we will talk about the switching advantages and we will talk about the MPLS performance. We will again try to cover and visualize this RD-RT working and MP-BGP through this real world implementation. So, but still, if you have any doubts, we can further discuss it, or maybe any doubts on the previous slides also. Let us try to consolidate our learning so far. We have actually discussed on the various operations that happens in an MPLS, how an MPLS label stack is created, what are control plane, data plane, what are the different tables in an IP MPLS scenario, and how those tables are created, how the data is transferred, and finally, why the isolation is required, how the isolation is achieved, and how an IP version 432-bit address is converted to a unique 96-bit address and mapped to its member, mapped to its VRF using a route target. Or maybe anything if you want to ask on the previous day as well, wherein we have covered on the basics of MPLS as such. Okay, does RTE and RTI keep changing? RTE and RTI will change. Yes, they will change. The RT export will become the RT import for that circuit. So for the data transfer, which will be between the C11 and C12, there will be a set of RT export and RT import. But the RT export of C12 will be the RT import of C11. So they will change, but import or export of one will be the import of another. So we can say that export is created first. That becomes the import of the another one. Yes. It will be treated as a VPN packet. VPN v4 or VPN v6 packet. No, that shim header has already been added. That label is already there. See, this thing is to achieve the customer isolation. Whatever we have discussed in this slide, that anyhow is happening and will always happen. On top of that, to achieve the customer isolation, this slide will happen. So it is an additional working of the MPLS. So it's like already some basic things have happened and those basic things itself are quite complex. Onto that complex basic things, this RT is being added. So that it will travel in this MP-BGP protocol. It will be between the edges. Why it will be between the edges? Because these routers, they will not open it. It will only be working on the labels. They will keep on swapping the labels, and it will be a BGP free core. Like from the last class, we understood that MPLS actually provide a BGP free core. So that's why this MP BGP, these arrows, they are between the provider edge. So the edge routers are only doing this extra job. The provider routers are happy and they are doing the simple swap.
Excuse me, sir.
Yes.
Sir, during telepresence as a service,
Yes.
sir, during that video conference, whether this VPN V6 or VPN V4 are also used, sir?
They are used. Whether VPN V4 will be used or VPN V6 will be used will actually depend upon the router that is used for telepresence. So the customer end router, if it is working on version 4, VPN V4 will be used. If it is working on IP version 6, then VPN V6 will be used. In the current practical scenario, VPN V4 is only used.
Okay, sir. Thank you.
Ankurji,
Yes.
actually, last class also we asked the MPLS. There are variants, no? IP MPLS, MPLS TP, T. This now you tell this MP BGP, IBGP, EBGP.
Yes.
Okay. So these are the different variants for different routing purpose, getting different functionalities.
What I would say is what we are discussing is the basic for everything. Is the basic like this RD, RT, this FIP, FIP.
They are okay, but we call IP MPLS nowadays. Earlier we called it is only MPLS, and one more variant MPL, the BGP, this MPLS TP.
Yeah, they are different. They are all variants. MPLS TP is the MPLS transport profile. Then you have even DMVPN. That is a different kind of MPLS. So there is slight difference between the normal IP MPLS and the MPLS TP. What I could tell you is that difference is in terms of the LSPs being unidirectional or bidirectional, or the operation maintenance roles that are more enhanced in the MPLS TP kind of protocol. But generally, by far, IP MPLS, which works on IP version 4 or IP version 6, is the most widely used.
Can we say like this? If traffic engineering is implemented, that is MPLS TP.
What is implemented?
Traffic engineering, TE.
No. It is not like that. Traffic engineering is again the basic concept of MPLS. Traffic engineering.
You tell this bidirectional. When it is bidirectional,
So
in case of MPLS, we use bidirectional. Bidirectional, we use only traffic engineering. When we implement traffic engineering, no? Bidirectional.
Not exactly. Traffic engineering in a simple sense can also be told that you want to use the underutilized paths. That can also be one basic form of traffic engineering.
There are so many.
Exactly. There are so many variants in that also. So just like that, there are so many variants to MPLS.
So, when between IP MPLS and MPLS TP,
Okay.
you say enhanced features with MPLS, that is MPLS TP.
Right, in some sense, yes.
Ankurji, before answering Anandam sir question, my straight question is, earlier I was hearing this MPLS for the last 10 years, but now suddenly people calling MPLS IP. What is the exactly difference?
There is no
exactly you want to
there is no.
why earlier they call only MPLS? Why now they are calling MPLS IP? What is the new thing is added to the old one? That is just I want to
There is no such difference between MPLS and IP MPLS. It's just that it is now being told more commonly as an IP MPLS. They are same. They are same. MPLS and IP MPLS, there is no difference. It's just the common thing that has become. Earlier it was being just called an MPLS, now it is called IP MPLS.
Now answer the Anandam sir. This one MPLS IP and MPLS TP.
There is a difference between MPLS IP and MPLS TP.
Please, sir.
It is clear, Vijay, it is clear. Only we have some additional features in MPLS TP, like congruent paths, bidirectional.
Is it more advanced? Is it more advanced than MPLS IP? MPLS
It
TP
is
more
advanced and it has its own application. It is advanced and it has its own respective application. It is not like that you replace MPLS IP with MPLS TP. It is not a replacement. It is a
railways are not using MPLS TP.
It is not required in the context of railways. That is what the question is being asked also, which is suitable in IR context. See, again, IR context, you need to understand MPLS is again a technology of service provider. It is not a technology of the customer. So what is suitable for IR? Nothing is suitable for IR because IR is not the service provider. IR will do its own routing, which he has to do. Neither IP MPLS nor neither MPLS TP is suitable for IR. So that's it.
So, Ankur, can I assume IP MPLS purely transports only IP networks from source to destination? In case of MPLS TP, not only IP networks like E1 networks, serial networks, other ATM networks can be transported through MPLS.
No, that assumption is wrong. Reason being, MPLS, the word MPLS, like we discussed yesterday, is multi-protocol label switching. So that multi-protocol implies that all underlying protocols, E1, Ethernet, frame relay, ATM, will be transported. So those different protocols will be transported in both IP MPLS and MPLS. No. There is no hardware change, nothing like that. And policies have to be changed. Yes.
Only communication part.
आनंदम सर लाइक जैसे पहले डिस्लैम इक्विपमेंट था हमारे पास में, बाद में जब रेलटेल लेके आया तो बोला आईपी डिस्लैम इक्विपमेंट है, बोथ आर सेम। बाद में आया नोमेनक्लेचर आईपी डिस्लैम हो गया। पहले से हम लोग यूज कर रहे हैं डिस्लैम इक्विपमेंट, बोथ आर सेम वर्किंग से पैसे।
Correct. Only adding some small feature, they are changing the names.
Yes sir, that is the only.
It is not changing the name, I would say. The industry is changing the name by adding features.
I'm not telling Railtel is changing. The industry changing.
Right, indeed. Just I have to add that disclaimer just for the better understanding.
Thank you, Ankurji.
And there's just one more question I guess we have skipped in the chat window. I can see it says that 15 reserved labels for implicit null are within 2 to the power 20, or they are separate from the reusable labels. They are within the 2 to the power 20 set only, because 20 bits are being fixed for the label, and in that only the first 15 are reserved. In that first 15 means number 0 to 15, something like that, in which number 3 is an implicit null. So you can check that RFC 3032 for additional details. If you want to understand what are those all reserved labels, that will be helpful. Okay, then, we will, after the break, we will be talking about this working once again through this slide, and then the advantages and the performance. So that's what
one more question, Ankur, I have. Ankur?
Yes.
Yeah, one more question. In this slide, whatever just now you have explained, and this 64 plus 32 bit, that is for IPv4. So 96-bit VPN v4, that is basically done at the service provider, at your place only.
Yes.
And depending upon the target, so you have mentioned that 64 plus 32, 96 bit plus root target you have mentioned. But what about the RTI? That also needs to be mentioned or not required?
So that's what I told, that RTI is actually created based on the RTE. So this RTE, if you see 100.102, is actually the RT import of this router. So RT import is not generated. RT import is calculated based on the RT export.
So once you know RTE, RTI can be calculated.
Automatic. It's automatic.
Automatic. Okay.
Yes.
Thank you.
This RTE is going to become RTI there.
Exactly.
Yeah. Correct.
Sir.
Excuse me, sir.
Yes.
Excuse me, sir. Yes, if C12 is communicating with C11, then RTE for C12 is RTI for C11. What if C12 is communicating with C21? Then does that RTE will remain same for C21?
See, first of all, in the normal scenario, they will not communicate. You will, because that will then be a security glitch. Okay, because in that case, what will happen? The data of C12 is going to C21. It has to be manually done, and the root target will have to be leaked into the root, into the information or the table of C2. They will not be saying E will be generated by C12, RTE will be generated here by C21. If they want to communicate with each other, these have to be manually leaked by using the command in the router. Okay, there is a question, what happens to connectivity between two Ps, that is two providers, like cable cut is there. So we have discussed it. We can discuss it once again. For example, this cable is cut, the cable between P2 is cut, but then there are other routers, right? P1 is not just connected to P2, it will be connected to P4, it will be connected to P5, P4 may be connected to P2 or maybe P3 or some other path. So it will automatically find the next best path. Hyderabad to Bangalore connection will disturb how it is restored. So that's automatic. That's what I said. It is automatic. It will wait for the expiration of some milliseconds and notification messages. Not even a single packet will be passed. Okay.
Then we will take a short break now. So 12:10, I think is time. 12:20 we'll meet again.
Certainly. Do that.